Hey everybody, so part 2 of my video. Um, so I just reached like the 60-minute mark for my previous video. I'm just trying to cut my videos to like an hour long. So here is part 2 of the video on using the TI84 calculator for both the AI and the AA. So these are some of the very common skills that you should see. I hope I did not miss any of them. Maybe I may, but if I did, please do write me a comment, and I'm happy to do another video if I missed out on any skills. Okay, so we came back to this whole linear regression and the PMCC thing. So what we did earlier was we found linear regression by using stat. We go to calc and we choose option 4. Then we chose all this option, which is L1, L2. Then we go to calculate, and we got all the values that we need here. So the best line equation, I'll just show you with the answer here. You should be able to write the answer that looks something like the best fit line equation, which is going to look something like this. Now remember, A is 2.2, B is negative 0.4, B is the y-intercept, A is the gradient. Okay, so you want to write this equation here. All right, so we can write something like when you are supposed to come up with the final answer for this, this is what you should be writing. Okay, so be y equal to 2.2x. Okay, again, because this is x and y, so obviously I should also be using x and y in my equation. Okay, so this will be x plus, let's just check the y-intercept again, it's a minus. So this should be minus. Since the y-intercept is a negative number, then we should put this to be minus 0.4. So this is the equation of the best fit line that will for this data that's given to us. And the correlation coefficient basically could be found under R value, which is 0.996 if you round it to 3SF. Now, just something to point out, if you do not see R when you do your linear regression, it's because you have not activated one of the features on your calculator. Now, on your calculator, before you do any linear regression, you need to go to mode. Make sure that stat diagnostics is always going to be turned on. All right, if you don't turn this on, you will never get to see R. Okay, all you really see when you do linear regression is just A and B. Okay, so just take note of that when you use the stat diagnostics. Okay, so that's really it for linear regression. Super easy. Okay, so let's clear all. Let's move on to the next bit. Oops. Okay. And next one, we're going to look at the Spearman rank correlation coefficient. This is primarily for AI students. So AA, you may obviously skip to the next bit. The next few parts, which is really going to be all primarily about statistics, which is not, I think after this is going to be normal distribution and binomial distribution. That will be something you want to look at, because that will be a common content between both the AA and the AI courses. Okay, now the Spearman, this is a very interesting concept for the AI students. So basically what it really does in a nutshell, when you use the Spearman, sometimes the question will tell you to use the Spearman, sometimes it doesn't, but most of the time it does. So what it does is that what Spearman does is that we know that the PMCC, what it does is to look for a linear correlation. Okay, so the assumption is that there is a linear relationship between the two variables. Now, but for the Spearman, we don't need the relationship to be linear. Okay, which means that you could have two variables to be correlated, but they don't have a linear relationship, and that's where you want to use the Spearman rank correlation coefficient. And that's where, instead of using the raw data given to you, you will have to rank them first. Okay, so I'll show you really quickly how we do that. Now, if you're getting like a raw data like this, now you should always have an extra column, and we're going to call this the rank. Okay, for both the revision hours and the biology score. I'm going to call this rank as well. I'm going to call this R, just in short. Now, what you need to do is to rank the revision hours for both the revision hours and the biology score, and you need to do it consistently. Okay, so let's say for the revision hours, I'm going to rank the highest revision hours to be rank number 1. So sorry, this is rank 1. then this will be rank number 2, then this will be rank number 3, this will be rank number 4, and this would be rank number 5. Okay, and the biology score, you do the same thing as well. This will be rank 1, this will be rank 2, 3, 4, and 5. Okay, very much a coincidence, okay, when it comes to this. So generally what we want to do when it comes to putting this onto the calculator is that we want to do the same thing like what we did for the Pearson correlation coefficient, where you just put in the raw data, but in this case we're not putting in the raw data. It's because we want to look at the ranks. Again, remember the ranks is because we have to rank this is because I tell you what, I think what I'm going to do is I'm going to change up a little things here, because the ranks are generally the same for both the revision hours, because I just want to highlight something so that it shows some kind of difference, because this is going to end up looking extremely weird in this case. So I tell you what, I'm going to just modify the data in this case, okay? Let's say, okay, because this is going to end up being a perfect correlation, and this is not realistic at all. So what I'll do is, let me try to change maybe this and this to be 5, and I'll change this to be 6. Okay, so there will be a slight change in the ranks for both the revision and the biology score. Okay, otherwise this is just unrealistic. This is going to be a perfect correlation. It's just not, it makes no sense at all. Okay, so this will be 1, this will be 2, then this will be, okay, then this should be 3, then this will be 4. Okay, so let's just change this as well. Okay, all right, then what I want to do now on the calculator is I'm going to actually put the ranks onto the calculator. So I'm not putting the raw data. Instead, what I'm going to do is I'm just going to put in the ranks. Okay, so let me just delete all the data here. And under L1, I will put in the ranks of the first set of data I have here. So it's 4, 5, 2, 3, 1. So I'm going to put 4, 5, 2. Okay, now again, I think this is not a great illustration, because I think there should be more data for this particular question, because in order for us to see a non-linear relationship, there should be much more data points than this. But I'm just trying to highlight the point on how we can actually use the calculator to work on this. Okay, so you put 3, 5, 2, 4, and 1. Okay, and we want to do the same thing. We go to stat again, we go to calc, we want to go to linear regression. Okay, under L1 and L2, this is going to be a high correlation for sure. Okay, again, it's all made up data. Okay, you're going to get 0.9. Okay, so the last value is basically what I want, which is 0.9, which is obviously a very high correlation coefficient. So you may ask, what does this 0.9 actually represent in this case? It means that there is actually there is a strong positive correlation between the ranks of the revision hours and the ranks of the biology score. Remember, we are not comparing revision hours against the scores. It's basically comparing the ranks. So you need to write the word ranks when you analyze the data. Okay, so saying that there is a positive strong correlation between the rank of the revision hours and the rank of the biology score. Okay, so you got to make sure you write the word ranks when it comes to a Spearman question, because remember, we rank them instead of using the original raw data of the revision hours and the biology scores. Okay, so I could have just changed the data a little more differently, but I just want to highlight the fact that if you are asked to use the Spearman, make sure you rank them consistently. The rest of the thing is just the same thing like what you do for the PMCC as well. Okay, all right, so I hope this clears up Spearman. All right, so then let's get down to the next question. Which is on normal distribution. All right, so back again, common topic between both the AA and the AI. So let's really take a moment and read the question. So it says the time it takes for students to complete a certain IB exam is normally distributed. So the key word here is normally distributed. It's always written for you if you're supposed to use normal distribution. With a mean of 85 minutes, standard deviation of 8 minutes. Calculate the probability that a student completes the exam between 75 and 95 minutes. And find the exam completion time that correspond to the top 5 fastest students. Okay. Now, when it comes to normal distribution, I always recommend you to draw a diagram. Okay, a diagram speaks 1,000 words. All right. So when you have a normal distribution curve that looks something like this, all right, you have the mean right through the middle. So I'll put the number 85 here. Okay. And the first part is basically asking if a student completes between 75, so 75 is going to be somewhere here, and I'm going to have 95, which obviously going to be on the other side as well. What I want to find is what is that area of this graph, which is basically this part, which gives me the probability that a student completes the exam between these two time frames. Okay, so again, we want to use the calculator to do this. And what we could do is we could go to second vars, and then we're going to choose normal CDF. Okay. So normal CDF, when you choose this little function here, this will allow you to put in the boundaries of the scores that you're trying to find the probability, which is between 75 and 95 minutes. Okay. So if I choose the lower boundary to be 75, the upper boundary to be 95, this is the symbol for the mean, which is 85. Standard deviation is just 8. Then it's all very self-explanatory, this one. So you're going to press enter. Then you're going to get the probability to be 0.789 if you round it to 3SF. Okay, so that would be the probability where a student is going to complete the exam between this two times. Okay, two time frames here. Now, then let's look at the next part. Okay, it says find the exam completion time that corresponds to the top 5 fastest student. Okay, so we want to find the time that corresponds to the top 5 fastest student. All right, so what basically this question is asking is that if I were to, that means I'm trying to find, let's say somewhere about here. We know that if you're looking at the fastest students, we're looking at someone who can complete the exam at a super fast time. So it should be a really small number. I'm trying to find out what this number is so that this part, the probability of this part here is actually going to be 5%. Okay, it's just simply 5%. Now 5% generally would be the same as what we call in decimals is 0.05. So that's a very, very small area that we're looking at under this graph here. Okay, and we're trying to find out what is this time that corresponds to the fastest student. So instead of finding the probability, I have already kind of given you the probability, which is actually 0.05. So we are kind of doing it in reverse now. All right, we're doing the reverse of what we're trying to find in the first question. So rather than finding the probability, we're trying to find the time. Now, there is a feature that allows you to do that on the calculator. Okay, so again, on the calculator, what I want to do is I'm going to go back to second vars. So I'll click on second vars. I'll choose inverse norm, which is option 3. Okay, now it will ask for the area. Now the area we just found was 0.05. It's the one that is in blue. Okay, that's why I say a diagram is so important. You need to draw it. So I'll do 0.05 here. Okay, the mean would be the same mean value we have here, which is 85. Standard deviation would be 8. The tail, now tail is basically the direction that goes. Now if you look at this, we are trying to find out what is the number or the time that goes with this area here. All right, so obviously this goes on the left side of it, so we choose the tail to be left. All right, if you're trying to find a number here, okay, and you're given the area to the right, then we will choose the right tail because we're given the probability or the area which is to the left of this number, so we choose the left tail for this one. Does that kind of make sense? Okay, so I'll press enter, then I'll go to paste and press enter, and it gives me the score to be 71.8, and this makes sense because 71.8 is actually smaller than 75. Now I'll show you, if you, let's say you have no idea how this whole tail thing works, right, and I'll show you why is it so obvious. Let's say we choose this to be the right tail for some reason, okay, which we know is wrong, and I paste it. Look at what happens to the value. It's 98.15. That's not anywhere, should be 98.15 should be on the other side. Does that kind of make sense now what the tail means? Because this number has to be less than 75, so that's why we chose the left tail. So it's all very, very self-explanatory once you get these numbers, and that means the examination time will just be 71.8 minutes. Okay, so that's how we use the inverse norm for normal distribution. All right, hope this makes a lot of sense to you. Hopefully you're following with me. I'm just hoping that this video is starting to make a lot of sense to you. Okay, let me just get the pen off my back and let's move on to binomial distribution. Okay, so hang in there guys, we're almost there. Binomial distribution, another popular question for both the AA and the AI students. So let's really get down to this, okay? So it says that a basketball player makes a successful free throw with a probability of 0.7. During a practice session, she attempts 12 free throws. Now this obviously is a very classic typical binomial distribution because number one, the total number of trials is given, which is 12 free throws. And the probability of success in this context would be making a successful free throw. That's 0.7. So if you have these two conditions and knowing that each throw is independent of one another, this has to be a binomial distribution question, okay? And I mean, let's put it this way. If the question is not normal distribution, then it must be binomial distribution, isn't it? Because that's the two types of distributions that you'll be learning in both the AA and the AI course, okay? So let's look at the first one, all right? Again, with the GDC, let's just make the best out of it and try to find the answer to this. Now, calculate each of the following probability. Makes exactly 8 free throws, and I need to find out the probability. So again, the same thing on the calculator, very similar to the normal CDF feature. All right, I'm going to go to second vase. I'm going to find something what we call the binom PDF. So we're not going to choose the CDF, but we're going to choose the PDF, okay? What binom PDF does is basically, if you are asked to find the probability of exactly a certain number of rows in this case. Now PDF basically wants just simply a fixed value, all right, while CDF is a range of numbers. So if you're looking at exactly 8, which is only 8 itself, you choose PDF, okay? So I'm going to choose PDF in this case. The number of trials would be 12 because we obviously have 12 free throws. The probability of getting a throw in would be 0.7, so P would be 0.7, which is the probability of success. And X value, remember X value would just simply be making exactly 8 free throws, okay? So I'm going to make this to be 8. Press enter, and that should give you the answer, which is 0.2311, okay? This makes a lot of sense so far, right? And in part 2, the probability that she successfully makes at most 8 free throws. Now read the question carefully. At most 8 is basically means 8 or less. So I'm looking at 7 free throws, 6 free throws, 5 free throws. So I basically need to find out the probability of all these free throws. But it's just too much work to do 8, 7, 6, 5, 4, 3, all the way down to 0. So there is a feature on your calculator that gets the job done. If we go to second vase again, you want to choose binom CDF. Again, when we look at a range of numbers, we look at CDF. The number of trials you want to choose again would be 12, because that's 12 throws you're making. In this case, we're going to choose 8. Now, when you do CDF and you choose P to be 8, what you are asking the calculator to do is to find me the probability when he makes 8 free throws, 7 free throws, 6 free throws, all the way down to 0. and you add up all these probabilities. That's what CDF does. It sums up all these probabilities in this case. Okay. Oh, sorry, no, that's X. I'm sorry, that should be X. P should be 0.7. What am I thinking? All right. Okay, sorry. Let me just fix this first. Okay, let's clear this one. This should be 8. Then P should be 0.7. Okay. So why we choose X to be 8 is because we're trying to get the calculator to add up all the probabilities of 8, 7, 6 all the way down to 0 free throws. Okay. That's the difference between PDF and CDF in this case. Then we go to paste. Then we press enter. Look at the difference. It's 0.507. That's the value of the probability where this player makes at most 8 free throws. Okay. Now it's question 3 that becomes a bit of a problem with the TI84. Okay. I think in one of my videos that I made before, I highlighted this exact scenario when you get a question where you're supposed to find the probability where, in this particular context, making more than 8 free throws. Now, what this question is asking is that you're supposed to find the probability of finding 9 free throws, 10 free throws, 11, and 12. So basically, it's 9, 10, 11, and 12, and you add up the probabilities in this case. Now, of course, you can do the binomial PDF like 4 times in this case, but that's a lot of work. Now, but the thing is, if you think that that's fine with you, you can actually just do binomial PDF and you do for 9, 10, 11, and 12 and just add up the probabilities. Now, your calculator in this case doesn't allow you to do anything which gives me more than 8 free throws in this particular context, because it only the calculator is being programmed in such a way where it only does anything which is like at most or less than, but it doesn't include things like more than, because it doesn't allow you to put in the boundaries for binomial distribution. So we need to work smart. Okay, so in this case, what you need to do, all right, there is an extra step you need to do, because we know that 8 free throws, we're looking at simply 9, 10, 11, and 12. Okay, so like I said, one way is you can do binomial PDF 4 times for each of this, and you add up the numbers. Now, what we have done earlier is that we found everything, the probability from 1 all the way up to 8 earlier. This is what we done in question 2. Sorry, it should be starting from 0. We found the probability from 0 to 8. Okay, we got the answer for that as well. But if you want to find the probability of 9, 10, 11, and 12, it's really not that bad, because we know that since you have 12 free throws, the total probability of making all this work would always have to be 1, because that's the highest probability you could get, right? Now, since we've just found the probability of you making from 0 to 8 throws, which happens to be 0.507, what we need to do is we're going to take 1, subtract this value here, and that's going to give me the rest of the probability, which is 9, 10, 11, and 12. All right, so basically what you need to do in this case is going to take 1, subtract 0.507. That's what you need to do if you see the word more than in a binomial distribution question. The other TI calculators actually can get this done because it allows them to put in the boundaries. So that's a limitation of the TI84. Okay, so please make sure you take note of this. So you have 2 options here. Okay, one is you can do the binomial PDF 4 times for 9, 10, 11, and 12. Another option is, if you have done part 2, you could just take 1, subtract the probability of finding the probability of making 0 to 8 throws. That's going to give me the probability of having 9, 10, and 11, and 12 throws. So you have to do 1 extra step in order to get part 3. Okay, so please bear in mind when you do the binomial distribution. Okay, all right, so let's move on. All right, this is the next 3 tests is going to be strictly for the AI students. So for the AA students, I hope this has been extremely helpful to you, but if I have missed out anything, please just drop me a message in the comments box below, and I'll be very happy to make more videos to help you with this as well. Okay, now AI students, please hang in there. All right, we're going to move on to the chi-square test of independence. Again, this is a very typical statistics question that you should be expecting. So let's get down to business. Now, so we got a data here, which is about finding whether if there is relationship between the gender and your favorite subject. So we got a raw set of data. So in this case, under the chi-square test, what we want to do is to make sure that we put all this data into the calculator. So we want to look at, in this case, we got two rows and 3 columns in this case, because we have 3 subjects and 2 genders in this case. Now, what you want to do with the calculator, oops. Okay, sorry about that. Okay, what we want to do is we're going to go to, sorry, let me quit again. So I'll go to second matrix, okay? So I'll say it again. So you want to go to, okay, let's clear this. So it'll be second, then I'll click on matrix. Now what I want to do is I want to go to edit, okay? I'm going to go to matrix A. I want to put in the data in this because you can only put in this data in the form of a matrix, okay? The first number in the matrix tells me how many rows I need and how many columns do I need in this case. All right, so number of rows in this case would be 2 rows and 3 columns. So I'll choose 2 by 3. Then I'll press enter. Then I'll just put in the data here. So that would be 35. I'll choose, okay, let me just make this smaller. I should have just made those questions a bit smaller. Okay, so 35, then I'll do 25 here. Oops. Okay, let me change the number, 25. This will be 30. Then this will be 20. Then this will be 30. And this would be 40 in this case. Okay, so I've got the data here. What I want to do is to go to stat, go to test, then I'm going to choose the chi-square test, which is option C. So we press enter. So we have the observed and the expected. Doesn't really matter. I'll show you what this basically means later as well. Okay, what we want to do is just go straight to calculation. All right, we go to calculate here. Press enter, and what we really want in this case is the p-value. Now this is the chi-square value. We usually use the chi-square value to compare that to the critical value, but in this case, since the critical value is not given to you in the question because it only asks you for comparing this at the 5% significance level, so you really want is the p-value, which is 0.05. okay, now 0.05 04. Now obviously you want to look at more significant digits as well, which is 0.0504. Now so since it's 0.0504, so now 0.0504, if you compare that to the significance level, which is 5%, but that's still bigger than 0.05, then since the numbers are bigger, so in this case you will fail to reject the null hypothesis. Okay, so your null hypothesis when it comes to a chi-square test, which is H0, is that we always assume that these 2 variables, which is gender and school subject, they are always independent. Okay, that's what we always assume when it comes to a chi-square test. Okay, so I'm just going to put independent. It's really hard to write with this pen, but you get the point. So it's independent between the gender and the favorite school subject, and H1, which is the alternative hypothesis, we assume that they are not independent. Okay, I'll just put NI to refer to not independent. So since we have the p-value to be greater than this, it means that we fail to reject the null hypothesis. Okay, because there's obviously not enough evidence for that. Okay, so obviously we have to so we failed to reject the null hypothesis. So in other words, we are kind of like accepting the alternative hypothesis. So in other words, we could say that both these variables, which is gender and favorite school subjects, they are not independent. Okay, obviously they are dependent on one another as well. So that's how you would conduct a chi-square test using the calculator. Okay, but we can make another video separately on the chi-square test for this one. Now, just want to show you something as well. Remember when we did the chi-square test calculation, we realized that there is this, I'll just show it to you again, stat. I'll go to test. I'll go to chi-square test of independence, which is option C. If you press enter, now you realize that this is observed data and this is the expected frequency. Now what observed means is that what you see from your experiment or what you see from your research, and expected is what math should have proven to be seen when it comes to the numbers. If we are, what kind of numbers are we expecting for these numbers here if we were to use pure maths in a way. Okay, so I'll show you how we can actually find these numbers here. Now if you go back to your matrix, which is second, and we go to matrix here, now you realize there's matrix A and B, right? Let me just click on A, matrix A. Oops, sorry, let me just go back in second matrix. We go to edit, let's choose option A. You realize this was the original set of data. That's the observed frequency. Now if I go back to second matrix again and I choose edit and I choose option B, now you realize that these numbers are different. Now these are the numbers as what we expect them to be for male and female taking these three subjects. So that's what expected frequency basically means as well. All right, if we were to use the chi-square test. Okay, so just make sure you know the difference, because sometimes the question may ask you on the expected frequency, and you could always go back to the matrix and use these numbers, and that should give you the answers as well. So you technically do not need to work out these numbers individually. You could have used the matrix feature to do it as well. Okay, all right, so that's really chi-square test for you. Okay, let's move on to the next bit. The goodness of fit. So the chi-square goodness of fit actually works very similar to the chi-square test of independence. Okay, but the only difference is that we're not looking at whether the two variables are independent or not. Okay, what we really want to know is we want to see if the observed frequency and the expected frequency, if there's a kind of something what we call a discrepancy between the observed and the expected frequency. So it's actually a much more subtle test. It's just really the concept of chi-square is always looking at whether if there is a relationship between the observed and the expected frequencies. Okay, but so in this case, if you read the question, it says that the snack company claims that the mixed nuts package of these almonds, cashews, and peanuts should come in this ratio. But when you take a sample of this, you basically get a different number of masses, which is 15, 35, and 50. Now this is most of the time this obviously will not go in the same ratio as well. Okay, so what we really need to do is we need to first find out what is the expected frequency. I'm going to call this EF, which is the expected frequency for the mass of these three different types of nuts. Now if we got 100 grams of sample and it comes in a ratio of 2, 3, and 5, so what we need to do is first we take 100 divide by the total number of parts here, which is 2 plus 3 plus 5, so that's 10 parts. So what we're really expecting is if we take 100 divide by 10, that gives me 10. So, and if I take 10 times 2, that gives me like 20. Then the next one should be 30, and the next one should be 50. Okay, so when you add up these together, that should give me 100 grams. Now this is what I'm expecting to see for the three different types of nuts, which is 20, 30, and 50. Now the peanuts looks good. It seems like they have the same right numbers, but these two numbers are still quite different in a way. Okay, so then this is what we call the observed frequency. Now the question is just basically asking, could we test it at the 5% significance level if the actual proportions is whether it's different significantly from the company claim proportions. Okay, so we're going to let the calculator do the job here in this case. So we do the same thing. We go to matrix. Now for a chi-square goodness of fit, there is no need for you to put in a matrix. Okay, what you want to do is we're going to go to stat, go to edit. Okay, I'm going to delete all these numbers again. Then we're going to put in the numbers here. So observed frequency, which is 15, 35, and 50, we're going to put it in L1. So it's 15, 35, 50 for L1. Then L2, you want to put 20, 30, and 50. 20, 30, and 50. Okay, so we have the observed frequency and the expected frequency here. Now I just want to be sure that the observed frequency comes first or the expected frequency comes later. Now if we click on the golf test, now it says that observed will be L1, expected will be L2. Now again, this is the default settings of this. Okay, now what I did earlier was that I put the observed first and I put the expected second, which is perfect, right? Because when I go to stat, when I go to test, what the calculator basically wants is that you should be putting the observed first, then you put the expected frequency under L1 and L2. Now, in the event, if you put the observed under L2 and expected under L1, then just change this to L2 and L1. Okay, so just make whatever necessary changes based on what you put into the spreadsheet in the first place. Okay, now so L1 and L2 seems perfectly fine. Degrees of freedom. Degrees of freedom in a chi-square goodness of fit test is you always take the number of data that we have here, which is 1, 2, and 3, and you subtract 1. So this is just going to be 2. Okay, then I'm going to go to the calculation here, press enter, and again I'm going to look at the p-value. We don't really use the chi-square value unless you are given the critical value. Okay, we can come to that in a separate video, but just in this particular case, which works all the time, is you could use the p-value, which is 0.353. So 0.353, let me just write this down first. Where's the pen? So 0.353. Okay, so this technically is actually less than 0.05. Okay, now but obviously before we do all of these things, all right, just make sure you know the null hypothesis and the alternative hypothesis here. Okay, again, this is a bit different from the chi-square test of independence, because in the chi-square test of independence, what we're trying to do is we're trying to find out whether the two variables are independent or not. But in the chi-square goodness of fit test, what we're trying to do to see if there is if the proportion has a significant difference from the actual proportions in this case. Okay, so it's quite a different type of question, but they both generally work very, very similar in this case, because of the fact that we're not looking at whether the variables are independent or not. Okay, so the null hypothesis, generally we could say that there is no because the p-value was 0.353 and the oh wait a minute, 0.353 is definitely more than 0.05, isn't it? What am I thinking? So let me just change this. So this is definitely bigger. So it's bigger, right? So if it's bigger means that, okay, so but anyway, let's just formulate the null hypothesis. So null hypothesis is that there is no difference in the proportions, okay? And then the alternative hypothesis means that there should be a significant difference between the proportions. Okay, but since the null hypothesis, since the 0.35, the p-value is bigger than this, so again we're going to fail to reject the null hypothesis. Sorry, this should be HO. Fail to reject the null hypothesis. Okay. All right. So just make sure you know the difference between this. Make sure you use the p-value. Make sure you know how to put these numbers onto the GDC as well. Okay. So again, remember, if the p-value is bigger than your significance level, that's where you fail to reject the null hypothesis for this one. Okay. So we'll come this to this. If you need any help on the goodness of fit, I could do a separate video. But again, this is all about making sure that you know how to put all these numbers onto the calculator. Okay. All right. Then let's move on to the final bit. Okay, let's clear all this first. The t-test. Okay. All right, so again, we're going to find out using a significance level of 5%, conduct an unpaired 2-sample t-test. Okay, what? Now the question, I just want to put 2-sample t-test is obviously you're comparing 2 samples here. They're not paired because one is looking at 2 different types of data here. One is basically starting with music and the other one is starting in silence. Obviously they're not paired. If paired data would be like, for instance, if a student were to if we're looking at the same student doing something before a test, or maybe doing something and want to compare what happens to his and you want to analyze his scores that comes after he has done some form of revision. So it's basically looking at the same subject but looking at a before and after scenario here. That's what we call a paired 2-sample t-test. Okay, but in the IB AISL course, we are always looking at 2 sets of data which are somewhat not connected, but yet you want to be able to find if there is somewhat a difference between the scores. All right, if someone in this particular context would be someone who studied with music, someone who studied in silence, is 2 different groups of students, and we want to compare the mean scores of that. That's where the t-test comes in. So it's what we call an unpaired. We always assume a pooled variance. What it means is that we always assume that the variance would be the same for both. All right, but in this case, obviously we don't know the variance, but we always assume that the variance would be the same. Okay. So and I'll show you why this is important on the calculator, okay, because there's a feature where you have to click on whether it's pooled or not. Okay, so when it comes to a t-test, I'll allow you to put in all your hypothesis. Again, the null hypothesis. The null hypothesis in this case should be where the mean should be the same, and the alternative hypothesis is that the mean will be different, because what we really want to find out is whether there is a difference between the mean. So basically we're looking at a 2-tailed test, but I'll come to that later. All right, but what we really need to do is to put in the data onto the calculator. So stat, edit. Again, let's just put in all the data here. So we have 85. We're going to put the one on music first, okay? So 85, 78, 92, 74, 88, 81, 77, 83, 80, and 79. Then I'll put the studying it in silence. We're going to put in the data as well. So it's 90, 86, 74, oops, sorry, it's 84, 91, then we put in 89, 93, 87, 88, 85, and 90. Okay, so what we want to do is we could, to do the t-test, we're going to go to stat, we're going to go to test, we're going to go to, now we want to choose the two sample t-test and not the t-test, because you have two different samples here. You only use the t-test if you only have one sample. Okay, so two sample, you want to click on, now you click data or stats. Now let me just show you the difference. You click on stats, okay, you have to put in the statistics. Now that's only if they give you like the mean, the standard deviation, that's where you put in stats. But most of the time you're going to choose data, okay, because you have already input the data into the spreadsheet. So list 1 will be L1, list 2 will be L2. Then under frequency, you could just keep it to be the same. Under this little section about the mean, okay, now this is always considered as the first set of data, and this is considered as the second set of data. Now we're going to choose this option is because it says in the question that we are supposed to find a difference between the mean score. It did not specifically say in this question whose mean is actually higher. Alright, so if it says that the music score, if we want to find out if there is a, if the mean score of music is higher than the silence, then we can choose this option here, which is greater. Alright, but in this case the question only says that we want to find out if there is a significant difference. So it could be bigger, could be smaller, we do not know. So we always choose this option, which happens to be what we call a two-tailed test. Now for this option here, we want to choose yes. This is by default, is always going to be yes. Okay, then you go to calculate here, you press enter. Now what this tells you now is that it's going to give you all the values that you need for this. So again, we want to scroll down, we want to find what's the p-value. Now again, the p-value is the one that I'm interested in because I'm always going to compare this to the significance level. It's 0.003. Now obviously this is less than 0.05. So if it's less than 0.05, it means that you're going to reject the null hypothesis. So pretty much what we are saying is that there is no difference between the mean scores. Alright, because we are, no, sorry, if we're going to reject the null hypothesis, means that we are going to accept the alternative hypothesis, which means that studying with music would be the same, there will be a difference between the mean score of this subject when you study with music and when you study in silence. Okay, so I'm just going to sum this up. Now if the p-value is less than the significance level, that's where you reject the null hypothesis, and the null hypothesis is that the mean score would be the same. Okay, so since we are rejecting it, then it means that the scores should be different in this case, right? Because we are kind of accepting the alternative hypothesis. All right, since you reject it, that means you are obviously accepting the alternative hypothesis in this case. Okay, so that's really it for the t-test, and that's how you put it onto the calculator. So do please remember the steps when to use the two sample t-test and the one sample t-test as well. Okay, now I just want to go back to this. Okay, was it this one or this one? Okay, now back to the chi-square test of this one again. I think what we did earlier for this one, I just want to show you something. I think I may have made a mistake earlier. If I go to second matrix, I'll do this again. Okay, so I think I put in those numbers here, and I'm going to go back to stat. I'm going to go to test, then I'm going to go to the chi-square test. So okay, then we calculate. So the p-value found was 0.0504, which is larger than 0.05. Okay, so let me just write this down again. think I made a mistake somewhere earlier. It just kind of dawned upon me that I may have said something that was wrong. 0.0504. This is bigger than 0.05. So if the p-value is bigger, alright, means that we fail to reject the null hypothesis, which means that you're kind of accepting the null hypothesis in a way. So what does that basically means is that there is basically no association between the gender and the favorite school subject. Okay, so no association. Okay, that means they're independent. Because I think I said the other way around earlier. Okay, so no association between the gender and the favorite school subject. Okay, so and that's really it for me from the chi-square test of independence. So just make sure you know how to put the numbers into the calculator, and hopefully these topics will help you. And again, if you think that there is any other skills from the calculator that could be applied to both the AA and the AI courses, just let me know, and I'm happy to make more videos on this. Alright, please. Alright, so that's really it for me today, and I hope you enjoyed this video. Thank you.